Okay, we're going to do another experiment with the hydrogen peroxide, but instead now we're going to be measuring the rate of the reaction so I can prove that the potassium manganate is a better catalyst. Okay, so we're going to quickly go over what the apparatus is. We've got here the conical flask, and this is going to be carrying out the reaction. It's going to hold the potassium manganate solution and the hydrogen peroxide. It will not use bubbles because it doesn't need to and it will just get in the way. This is the finger of an old lab glove going with a small adapter, which you can just about see, into this green tube. This will be on top there, and I've checked it is just about a good seal, so we'll have to assume it will be perfect because I don't want to think about it for any longer than I have. This green tube goes down into the water, so the gas will not escape, into this graduated measuring cylinder. This has been filled with water up to just about there, and it will bubble through, produce the oxygen gas. It will slowly be produced, going down and down and down, and then until it reaches 100 millilitres, where I can't measure anymore. So, I can't measure from 0 to 10 because it's not that accurate, and I'm going to have to set up a camera thing because I'm not going to be able to hold the camera and quickly jot down things. So, I have to figure something out. But yeah, let's go make the solutions. Okay, so I've got the solution, got the beaker. It's going to go into there. I've got the results table that I'm going to be making. I'm going to quickly have to add this to this whilst I start a stopwatch with my foot, which is very technical, whilst quickly adding this on. Then in 5 seconds I need to be there to note down the volume. It's gonna be a bit difficult. Okay, so the first few seconds I missed the first recording, then it started increasing more than expected. I noticed I had to keep swirling it for it to be produced, so I'm probably going to have to do this again. And then I dropped it, which was odd, and it reached 100 cubic centimetres in 30 seconds. So it's going to be more difficult than expected to record. Okay, let's make some potassium permanganate. This is insanely hot right now, like about 40-45 degrees Celsius. Okay, finally ready for potassium iodide test 2, because the first one didn't go so well. Meaning I might do another test run for the potassium permanganate, I'm not sure, depending on how well it goes. Might take the average, it seems sciencey. Okay. This time I'm going to swirl it, not drop it. Haven't thought of anything to stop me dropping it though. Sure, it'll be fine. Okay, so, just like before, it filled up over the entire thing within about 30 seconds. So, the potassium permanganate one is going to be very difficult to record, because I'm assuming it's just going to go 100 immediately. Oh. But this got much more clear results because I didn't drop it. But because I didn't drop it, there wasn't a momentary pause, so the average is going to be a little difficult. So I think I might just use the second run that I didn't drop. It's still going. It's not going to stop for a while. If I give another swirl, I'm fine. Again, it's very hot, so yeah. There's another reason I'm only going to do one run for the potassium permanganate, which is it produces quite a lot of residue inside the conical flask, and I can't be bothered to clean it up every single time. So I'm only going to do one. Okay, ready? Because I'm not. Okay, so like expected, there was an immediate massive burst of oxygen, which I completely missed all of because I was slow to add it in. There's even some that I didn't even manage to use because it was so fast. It filled up all within 25 seconds, but it's slightly inaccurate because there was a massive burst of oxygen that I could have collected but failed to collect. So I probably need a lab partner, which I don't currently have. But if you mix it like the other one, it's a whole lot faster. And it's already insanely fast. So, yeah, potassium permanganate is an insane oxidizer. And oxygen gas is fun. Okay, that's pretty much this video. I'm going to put up a few graphs in a sec, but yeah.
Okay, so on the bottom left we have what the graph actually is that I recorded through my results of the reaction. It wasn't completely accurate because I did drop it several times, didn't swirl the potassium permanganate, and lost a lot of gas. So on the top right, I've also come up with a new graph that is what I was expecting it to probably look like. As you can see that there's a much larger difference between them. There's a slightly larger rate of reaction overall for the potassium iodide, but its short-term start is a lot different from the potassium iodide and potassium manganate, as potassium manganate immediately produces loads of gas rather than slowly building up to the rate. Okay.